Hello everybody, welcome back to my channel. Controller Marcos here. Usually I'll be posting VATSIM stuff and video games related to aviation, but I really wanted to make this video, and it's like 1 in the morning right now, so if I stumble across some of my words, please excuse me. So I wanted to make this video because I know there are student pilots out there stuck in ground school, that are stuck in flight school, and that don't know the relationship between indicated altitude, the altimeter setting, and pressure altitude. And that's what I really wanted to talk to you about today. Uh, if I do make any mistakes, please, guys, do not hesitate to correct me in the comments. I know I'm human. I am probably gonna make some, so please do not hesitate to do that. I take criticism, so don't hesitate to do it, guys, because I really would like to change, in near future videos. Um, that feedback can 100% help me and help you. So let's go ahead and get started. Um, Before we do get into the math, though, let me start you with this. Your altimeter isn't actually measuring altitude. It's measuring air pressure. And that's important because air pressure changes not just with height, but also with weather conditions. And today what we're going to see is how a change in altimeter setting can make your indicated altitude different from your pressure altitude, and why this matters every single time you fly. Our table of contents are pretty simple. It's three things, and the first one is define pressure altitude. Number two is use the standard altimeter conversion equation, which we're going to speak about later on. And number three is you're going to work a sample calculation and interpret the results. This is very simple. It can be complex if you don't pay attention, but I think you can all pay attention. The famous question is here. An aircraft altimeter is set to the standard pressure of 2992 inches in mercuries and reads 8,500 feet. The local altimeter setting at the airport is 2952 inches in mercuries. What is the aircraft's pressure altitude? Show all steps and explain the meaning of the result. Frame the question, take a picture, stop the video, do what you need to, make sure you have that question down. And let's go ahead and work it out together. So, I want you to first take a look at the formula, okay? Here is basically a shortcut. This is a shortcut formula. And we start with our indicated altitude, then adjust it based on the difference between the standard atmospheric pressure at sea level, 2992 inches of mercury, and the current local altimeter setting. I know you're about to ask this question. Why would you multiply by 1,000? Why would you do that? Okay, I got you. Usually people do ask that question. Because in the standard atmosphere, each 1 inch in mercury change in pressure corresponds to roughly 1,000 feet of altitude. If local pressure is lower than standard, you add your indicated altitude. If it's higher, you subtract. It's super simple. You get your pressure altitude equals your indicated altitude plus 29.92, the altimeter setting, and multiply that by 1,000. That is the easiest thing to do. Okay? Now, let's look at our given data and look at our step-by-step. So our given data is as follows. We have our indicated altitude, which is 8,500 feet. We have our altimeter setting at 29.92 inches in mercuries, which is our standard. And the local altimeter at the airport reads 29.52 inches in mercuries. So the question now remained, what is the pressure altitude? So let's go ahead and reframe the problem. We're at 8,500 feet, indicated. Remember, indicated with the altimeter set to standard 29.92 inches in mercuries. The local altimeter from the ATIS is 29.52 inches in mercuries. This tells us the local atmospheric pressure is lower than standard. Before even calculating, you should predict, will pressure altitude be higher or lower than indicated? Since the local pressure is lower, we expect our pressure altitude to be higher. So let's look at our step-by-step. First, you're going to subtract the local setting from standard. 29.92 minus 29.52 equals 0.40 inches in mercuries. Next, you're going to multiply that by 1,000 to get the altitude correction in feet. 0.40 times 1,000 equals 400 feet. Finally, you'll add that to our indicated altitude, 8,500 feet, plus 400 equals 8,900 feet pressure altitude. This is the altitude that matches the international standard atmosphere for current pressure. And it is as simple as that. Okay, let's look at our interpretation. Because the pressure is lower, our pressure altitude is higher. This matters because aircraft performance charts, takeoff distance, climb rate, engine performance are all based on pressure altitude, not indicated altitude. In higher pressure altitude conditions, engines produce less power, wings generate less lift, and true airspeed for the same IAS is higher. For IFR flights, once above the transition altitude, we use the standard 29.92 inches in mercuries to maintain separation. Pressure altitude is what ATC uses to ensure that. Like I said, couldn't get any simpler than that, guys. I want you guys to take a look at the visual diagram that I'm about to show you. This is where a picture is worth 1,000 words, and it is very simple, guys. Here, our altimeter is at 8,500, and we can see that here, 8,500 feet. Over here is a pressure versus altitude curve chart. See where 29.92 intersects and where 29.52 intersect. So look at where they intersect, okay? Excuse me. Notice the vertical distance between them is about 400 feet, and you can see that depicted here in the chart. That's our correction. Simple. All right, now we're going to do some little practice questions. They're very simple. Let me read you the question. Number one. Let's start with number one. If indicated altitude equals 3,200 feet, altimeter set is to 29.92, local equals 30.12, pressure altitude equals what? So, start by noticing the sign, okay? The local pressure is 30.12. That is higher than the standard 29.92. So our difference, 29.92 minus 3.12, is negative. That negative sign tells us the correction will reduce the indicated altitude to get the pressure altitude. Now, doing arithmetic precisely here, super simple. 29.92 minus 3.12 equals negative 0.20 inches in mercuries, which we convert to feet by multiplying by 1,000. Remember what we said? We multiply by 1,000, which goes now to negative 200 feet. Add that to the indicated 3,200 feet, and you get 3,000 feet pressure altitude. Bada bing, bada boom. You got it, guys. Now, let's go into question 2. If pressure altitude is required to be 12,000 feet and local setting is 29.72, what indicated altitude corresponds when altimeter is still set to 29.92? Okay. Here we have pressure altitude first, which is 12,000 feet on the standard pressure scale. We want to know what the altimeter will show when set to the local QNH, aka inches in mercuries, 2972. Using the same conversion, compute 29.92 minus 29.72 equals 0.20 inches in mercuries, which corresponds to 200 feet. And since the local pressure is lower than standard, 2972 and 2992, the difference is positive, and therefore we add the correction to the indicated altitude when going from indicated pressure. But because we're solving the inverse problem, we subtract 200 feet from the pressure altitude to get indicated altitude, and that gives us 11,800 feet, guys. It doesn't get easier than that, guys. It does not. It is super simple. 2 questions here. I mean, I should have told you guys to stop the video and you know solve it before you heard my answers. Um, so let's wrap it up, guys. Um, remember the formula: indicated altitude plus 29.92 minus local setting times 1,000. Okay, and know the sign. Lower pressure means you add to get pressure. Altitude, higher pressure means you subtract. And most importantly, understand why. Why pressure altitude is what performance data and ATC use. So getting it right is basically the key to safety and efficient flying. There's no more than that, guys. Guys, if you did enjoy the video, please just give me a thumbs up. You don't even need to subscribe. Give me a thumbs up. Make sure you like it. If you're interested in, looking at more of these videos and me making more, leave some suggestions down, and I'll see what I can do. I'm, doing the best we can, guys. Thank you for, watching, and I appreciate you guys. And we'll see you guys in the next one. Thank you. Bye-bye.